STEMology, the Young Scientist Survival Guide, session number 10. Welcome. You're listening to STEMology with Alina Adams. And I just want to say that I'm so happy we made it here to double digits. I mean, it's crazy that we're in episode 10 already. I feel like this has been so rewarding. And if you've been with me from the beginning and watched over the last couple of weeks, I just want to say thank you so much. It's for my few loyal viewers that I'm still with it and still producing content with even more enthusiasm. So thank you 100 times for listening every single week. I love y'all. But to continue on, I'm here today with a special guest, a friend, and a future graduate from UMKC with a double degree in biology and chemistry. Thank you so much for joining me today and taking some time out of your studying to be here. I really appreciate it.
Oh, hey, Alina, thanks for having me. I'm really glad to be here.
Awesome. Well, today's topic, as I mentioned in the last episode of STEMology, is about research articles. For the young scientist, a freshman, and I can't even lie, myself at times, reading scientific literature can be pretty intimidating.
Yeah, finding some good research can be really time-consuming, irritating, and just plain difficult. And I mean, we've all been there. You know, we've all started out as freshmen, having no idea how to find a good research paper, and even the two of us who are about to graduate, and we're going to be having a degree in this thing right here. We still have trouble, right?
Yeah, we still have our little hiccups.
Oh, God, it's still challenging to try to find something that's interesting and that you understand even.
Yeah, and you'd think with practice and experience it'd get quicker too.
No.
It always takes forever and it's always so frustrating.
Long. It takes so long to find a paper that you're looking for. Like you just said, even if you're spending all this time like getting better at it, it still takes hours.
Hopefully we can help you all so that you don't make the same mistakes that we did and maybe you can catch on a little quicker.
Exactly. We want to kind of break down this process and make it a little bit more simple just so you guys don't have to go through the exact same struggles that we did.
So what even are these research papers that we're talking about? What is a publication?
Well, usually a research paper is trying to analyze perspective or argue a certain point. Regardless of the type of research paper that you're looking for, research papers present the author's hypothesis backed up by others' ideas and information. I mean, you can scroll to the bottom of these research papers and you will see hundreds of citations because not one person's doing all this research. Mm-hmm. They are gathering and compiling all of it in one place. And so this is a skill you're going to have to get really good at if you want to be in this STEM-dominated field. Alina, I mean, how many hours have you spent online trying to find just that perfect paper?
Oh my goodness. I could talk about that forever, but hours and hours and hours. And it's something that you do get better at. You learn the little tips and tricks of how to find what you're looking for quicker, but it's always a process.
Exactly. Where'd you find all your research papers at first?
My favorite is the National Institutes of Health. I usually start there or PubMed. Kind of depends on the paper that I'm looking for.
Gotcha. I always like to start at the NCBI, which is the National Center for Biotechnology and Information. They almost always have some of the most complex papers, but after a while, they make so much sense. And you can actually even do your own experiments on NCBI, which is really fun.
Really?
Oh, yeah. Like, we were doing research, all this COVID stuff that's going on right now. I was doing multiple sequence alignments on NCBI, and they publish them, and they show you what each genome and protein matches up with what species. It is fascinating.
And that's the beauty of research.
I know, right?
When they're peer-reviewed, you can go back through and replicate the experiment.
Exactly.
So awesome.
And if you have no idea the few that we just talked about, the NIH, the NCBI, and PubMed, you can even use Google Scholar. I mean, Google Scholar is a great resource. It's much more accessible for a freshman. They usually can find it much quicker, and it has a lot of advanced settings that you can narrow down very, very quickly.
I'm pretty sure Google Scholar was the first thing I'd ever used, first database I'd ever used back in high school. So just to recap, the NIH is the National Institutes of Health. The NCBI is the National Center for Biotechnology Information. PubMed is a public site for most medical-based articles. Google Scholar is a much more refined, like he said, but it's a good place to look for articles, books, journals, all that.
And one of the other ones that I use a lot is called Core. It's actually the world's largest collection of open access research papers, and I think we looked today, and it had 190 million papers that we could look at. And it's just crazy to think that there's so much information out there. Yes. You're never going to be able to read all of them.
Hey, there's still a lot more work to do, though. Our next generation, we're so
important.
Exactly.
And another place I always look is the library. Like, I know that the online resources from our library or even the public library is amazing how much you can find there.
Sometimes you can even just Google specific journals themselves. So maybe a cardiology paper, the APA, American Psychology Association.
And just know that this isn't a full list. This is always expanding, and if you find a research paper somewhere else, just use it. There's nothing wrong with that at all.
Yeah, these are just ones that we use often. It doesn't mean that they're the only ones or that they're even the best ones.
Exactly.
I would also suggest asking people with a little more experience around you. So your professors, your peers, librarians, you never know what they could provide, what information they can add to your search.
Especially professors, because professors will give you papers on the class that you're in, and I think that that is so interesting whenever you go beyond the scope of the class, because it really makes you understand that class a lot more.
So let's say that we found our online database. So what's next? What do we even type in?
So a lot of times these research databases are based on keywords. So every single paper is going to have 4 or 5 keywords that is defining that paper. And all you're going to have to do is you're going to have to start some trial and error. You're going to have to put in some keywords and try to figure out what exactly you need to put into that database to get out what you want. So like the other day, I was looking up new treatments for schizophrenia. And so you type in schizophrenia and in all caps and then experimental treatments. And that will give you exactly what you want, hopefully.
Yeah,
right?
that's the idea.
You're
supposed to point you in the right direction.
Exactly. And if that doesn't get you anywhere, you're going to have to modify a little bit.
Yeah. Something I learned is a word that you think might be obvious to give you the result that you are looking for might not be obvious to the database. So you just have to keep trying and plugging in different words, trial and error, like he said. So these keywords are not case sensitive. They don't even sometimes have to be spelled correctly.
Right.
But they'll figure it out, and it might point you in the right direction.
Exactly. And then so that comes the next point. You put in your search, you're reading some of the titles, and maybe you don't even understand what the titles are saying. What do you do then?
I mean, sometimes I just look at them and I'm like,
ooh. Let's move on.
Yeah, you're like, let me try something different.
Yeah.
But if you just take a second, look at the title and see the words that you do understand and what does make sense, you can usually go from there using your context clues, using even just Google the words that you don't know.
Exactly. Google everything that you don't understand. There is no penalty or harm in Googling things that you don't know. Even in something as complex as biochemistry. You Google one word, maybe the one word that links everything together, you understand it.
Yes, so it doesn't have to be something super savvy, or sometimes you can just figure it out.
Exactly. And then let's say that you are looking at all these titles and it's nothing of what you're wanting. Like not one single paper is what you want. Okay, go to the next page. Read the next page of
Go
papers.
to the next page.
Exactly. If you look at the bottom, there's some numbers. It usually says page 1, page 2, page 3. There are so many articles out there. And, let's say that you look through a few pages. You don't like those either. Next, go to a new database. Don't stop your search when you don't find it immediately. You got to keep pushing.
So how do we know that a publication is good? How do we know that we've found a good, valid, reliable paper?
Well, a lot of times these sites like NIH or NCBI, they're not going to be putting just any old publication on their site. They're going to be reviewing the paper and making sure that it is credible, the author's credible, they use plenty of sources. There's a lot of things that go on behind the scenes that these databases do. So if you're going to find a paper on NIH or NCBI, it's trustworthy. You know that it's going to be okay to use.
These are papers that have been through it. They've been critically reviewed at every angle by more than one scientist, too.
Yeah, that's the big deal, is that a lot of these places are peer-reviewed. It's not just one researcher making these bold claims.
All right, so it looks like we're in a pretty good position here. We found our paper. So it seems the only thing left to do is to dive in and actually read it.
It's going to be difficult when you first start reading it because there's all these big words and these acronyms. That is one thing about biology that drives me wild, is that they will shorten everything that they can to 3 letters and a number. Yes. Everything. It's ridiculous.
There's actually usually, if you scroll towards the bottom, maybe before or after the references, there's usually an abbreviations list, just as a quick tip if you struggle with that
it's
too.
Very, very helpful.
So let's say you found this paper, you love the paper, you think it's exactly what you're looking for, but you're struggling to understand a few terms. Where do we turn then?
One of the best places I turn to is a professor. Somebody exactly. In that field that knows exactly what they're talking about. I can't tell you how many papers Dr. Mohan has given me and expected me to understand. And I read it for about a week, and I come back to him and I say, I have no idea what this paper says. Like, I'm looking at words, I am reading the words, and I am lost.
Google,
exactly. You Google all the terms you can, but sometimes, that's not even good enough.
Yeah.
So you go to a professor, and a lot of times these professors will have office hours, and they will sit down with you, read through it with you.
Man, we love office hours.
Oh, we love office hours. And so just make sure that you are asking. You're asking those questions. Don't just come across a term that you don't understand and just move on.
Yeah, I promise nobody's going to think less of you or think any differently if you have questions about a paper as difficult
Exactly.
as whatever the subject is.
I guarantee the professor will actually think more highly of you because you're asking that question.
It looks like reading is pretty difficult, doesn't it?
It is pretty difficult. Maybe that's why they have the cars section on the MCAT.
Oh
right?
my gosh, let's not even go there, please. All right, so all of this sounds like a lot of work, doesn't it?
It is, but welcome to STEM. Yeah.
So I just wanted to add as a last note that if you are in need of printing a paper or if you're interested in reading the whole publication itself, it helps if you specifically search free full-length PDF forms of the paper. So nothing is more frustrating than finding the perfect paper than having to leave it behind because you don't want to pay the $30 fee to own it. Today, we learned what a research paper is and the purpose of them. We discussed where to find them, how to decide if one is right for you and what you're interested in, and lastly, how to go about understanding one. So Holden, is there any last advice or comments you'd like to give to students as they embark on their STEM journey?
Let me hop on my soapbox a little bit for a second. I will say that I think one of the best things an undergrad can do in any STEM field, whether it be biology, chemistry, engineering, physics, anything, you need to be getting into a research lab. It is wonderful. So I really recommend getting into a lab and investing some time.
There's also just the overall experience in the environment of being in a lab, being around people who are as invested and interested in learning as you are, the specific subjects. So even if you feel a little intimidated about being in a lab or around people where you feel like they might know more than you or you feel like you're not prepared for something like that, the best thing you can do is just dive in and go head first and just really immerse yourself in it because you'll figure it out as you go. Nobody learns from a textbook.
Exactly.
Really. Lab work. I feel like you really have to be in the lab to understand. In the next episode of STEMology, I gathered a few friends from various majors for a discussion about how to get involved on campus, why it's important to do so, and how to find the right organizations that fit your personality and schedule. Real quick, I would like to ask if this episode answered a couple of questions for you. Was there anything we can explain in a little more detail? Please share and subscribe so I can continue to provide content that matters to you. You can go ahead and send in all of your questions and comments to the show at STEMologyYSSG@gmail.com, or you can reach out to me on our Facebook page or Twitter. Thank you for listening to our 10th episode of STEMology, a young scientist survival guide. Tune in with me, Alina Adams, for episode 11. Get involved. See you next time.